Good morning or good afternoon, depending on where you're joining us from. Thanks for joining our webinar, How to Leverage Log Data for Effective Threat Detection. We have Tom Diakino here, a Senior Security Engineer at Alien Vault. I'll go ahead and hand it over to Tom now.
Thank you, Vincent, and thank you to everyone on the phone who is joining us for this webcast. We're excited to have you. My name is Tom Diakino. I'm a Security Engineer with Alien Vault, and I promise the little alien icon next to my name is purely symbolic, not actually from another planet. But my intent today with this presentation is to keep it lighthearted and amusing, as well as informative. I hope that comes across, and I hope nobody takes offense to some of my silly representations and analogies that I'm going to provide for you here today. But with that, let's go ahead and get started. So we'll talk a little bit about the challenge that we're trying to overcome here, which at the end of the day, you know, lots of people talk about log management and, you know, the effort of collecting data from around your organization, but, you know, there's a purpose for doing that, and really it comes down to achieving a better security visibility for your business, right? And so we'll address a bit about that challenge. And talk about what we refer to as the widely pursued solution, or the sort of more traditional approach to log management. And we'll do a little cost-benefit analysis, kind of high level, but I think you'll get the point. So after we kind of look at the perspective from how it's most often being addressed, we can look at, you know, sort of an alternative approach, or something that we choose to focus on from a more strategic point of view here at Alien Vault. And then we'll wrap it up with a little overview of the Alien Vault solution, and I'll show you some actual, you know, capabilities within the product, or some illustrations of those capabilities within the product, so that you can get a sense of how the system is going to help you solve some of these problems and actually see it work. And then we can address some Q&A afterwards. Okay, so the challenge, it starts just purely with humans interacting with technology, right? And the issue here is that while technology is intended to, you know, create value for us, or to help us sort of be more effective in our daily efforts, like you know, simple things like communication, you know, there's unintended consequences that often come into play. I mean, who hasn't been impacted by a simple, you know, autocorrect in a text message, right? And it's seemingly, you know, usually pretty helpful, but there are circumstances where you know, that technology ends up having a really grave impact that you really didn't intend. And you can sort of associate this in the IT world with things like technology that we deploy to help our businesses be effective, and that technology ends up creating risk for our organization, things like vulnerabilities that are present as a result of adopting that technology. And so that's kind of one of the challenges that we have to deal with here is, you know, we're adopting technology to help us become more effective, but at the same time that technology is creating more risk for us, and therein lies sort of the security paradigm that we have to work with in IT organizations. And then we've got another element on top of that, which is, at the end of the day, our users have to be effective with the technology that we place in their hands in order to run our business, right? And there's a learning curve there. It's sometimes the simplest things can seem very, very challenging for an end user, and the net effect of that can be, you know, human error resulting in significant impacts on the organization as well. And so these are kind of two significant challenges that we need to, you know, wrap our heads around from an IT standpoint, and we've got to kind of sort through all of this stuff and differentiate this kind of activity from the things that are actual threats out on the internet that are impacting our organization, you know, threats inside that are potentially impacting the organization. And so, you know, all of these things kind of coming together are what we're really trying to wrap our head around, right? And at the end of the day, it comes down to, you know, how do we detect the actual problems that are in our environment, right? I mean, that's what we're trying to achieve, is what are the attacks that are coming in, or the threats that we're facing, what systems are being impacted by those threats, and how can we track that stuff down and get real visibility on it. And it's funny because we can in IT literally have you know, a mission critical server go down and nobody notices. But you know, if somebody loses access to Facebook or YouTube or whatever, IT certainly, you know, gets wind of that very, very quickly, right? And so it's just a matter of being able to, through monitoring systems, help us address this challenge where we're getting focus or getting visibility on those things that are actual critical systems, you know, that are impacting the success of our organization when we lose that functionality. So that the widely pursued solution that the market has sort of adopted overall is this concept of log management, or SIEM. It's, you know, there's some overlap there. Some elements of log management overlap with SIEM and vice versa, but collectively they kind of are used in combination to try to address this problem. And there are a couple of caveats that go along with this traditional approach, which I have listed here, and they're essentially, you know, the approach of collect everything. So anything that generates a log in your environment, pull it in, put it into a log management solution for long-term storage, do analysis on all of that data, do correlation on all of that data, and store it for long-term periods, right? So you've got retention requirements associated with compliance, etc., and keeping that data forever is some of the elements of that. And I mean, you can really take this to the nth degree. I mean, you can push it beyond, you know, collecting data from just security devices and go all the way down to the printer level, right? Do we really need to store logs from, you know, our printers so that we can see Michael Bolton getting frisky with the fax machine, right? I mean, there's some point where we need to say, okay, you know what, enough is enough. All of this log data is creating a significant amount of cost, and it's not bringing the value that we need to justify that cost, right? And that's kind of the cost-benefit analysis that I want to talk about here. Is, you know, you've got all these devices that you can deploy in an environment that are going to generate some information, and when you really take some time to think about it, how much value is, you know, are you going to get from all of these individual point solutions, and then taking the time and the resources to integrate them and bring them all together into a single log management solution? How much value is that really going to create for the security of your organization or the stability of your organization? And so this is kind of, like I said, where that cost-benefit analysis comes in. What's the hardware cost associated with going down this path? You know, where you need to collect everything, analyze and correlate everything, and store everything. There's this sort of notion in IT that disk space is cheap these days, right? That, like, you know, hard disks are very inexpensive, and for a typical desktop machine or a laptop or something, that may be true, but when you start getting into enterprise-grade storage, it's definitely not cheap, especially the high-performance stuff that's required for a log management solution or a SIEM solution to be effective, right? We're talking about SAN storage. And it's got to be, you know, high read and write, you know, I/O performance rates. And this stuff is expensive, and we're talking about cramming literally terabytes of logs into this high cost storage. And, you know, when we really stop and think about it, how many people do I have accessing this log data, actively using it, trying to solve problems around the data that's being retained there. And in most cases, it's actually not very many people that are interacting with this data, that are getting value out of this data. And then, how effective is the automated analysis or correlation really going to be when you're looking at so much data coming into a system? So if you've got all this log data around your environment that you're bringing in, you're correlating and trying to make sense of on the back end, this correlation effort is very CPU intensive, it's very memory intensive, and at the end of the day, it's an issue of garbage in, garbage out. I mean, the more sort of nonsense information you feed the system, the more nonsense information you're going to get out of it, right? So a SIM solution that does correlation is only going to be so intelligent for you. There's a limit to its capabilities, almost guaranteed. So not only is there a significant cost element involved with doing the processing of all of this log data, but there's also, that the value that you get out of it is limited when you're really pumping it with just tons and tons of information and getting to that point where that the data that's coming back out of it that's supposed to be streamlined or supposed to be, very, very tuned or focused for your analysts, even the correlation data starts to become a challenge to deal with. And what's the human resource cost? I absolutely love this graphic. I think it's hilarious. This guy is just at his wit's end, right? And when I think about an analyst trying to look at thousands and thousands of incidents that are being reported over the course of a day, this is the guy that I imagine, right? I mean, he's basically going through just scores and scores of log data, trying to figure out, where is this, needle in the haystack that I'm after. And I'll tell you a quick story. I actually did some work with a few folks that were at an organization that had a huge security operations center, and they had somewhere in the neighborhood of 50 analysts deployed, just doing reviews of the log data that they were collecting. And they were doing something in the neighborhood of 50 million events per hour, which is an immense amount of data to be collecting in a SIM world. And these guys were part of this team that had a mandate to basically touch every single event that was collected by the system. So every one of those 50 million events, they had to, at least, indicate with each one of those events, basically applying an annotation to the event to show that that the log had been touched and reviewed by an analyst. And you can imagine those guys basically looked like this guy. I mean, it's just not even possible for an organization, even of that size, to achieve. How many alerts can a person realistically review in any given day, right? And if you're cramming the system with tens of millions or hundreds of millions of events per hour or even per day, the amount of correlated data that it's going to present is going to be immense, and it's going to be even a challenge just to review that correlated data. So those are kind of the significant challenges that the typical log management solution and typical SIM solution create in an environment where we've got lots of information to collect or lots of data to store. And the benefit that you get from all of that effort and all of that expense is pretty minimal. I mean, if you go do some searches around how SIM is, just do a Google search to look into how SIM is kind of failing to deliver on its promise, you'll find tons and tons of articles out there about reports of companies that are just entirely frustrated with their SIM deployment. The money that they've spent on it isn't creating the value that they expected or giving them the return that they intended when they made that investment. And so at some point we've got to take a step back and say, hey, is there a better way to do this? I mean, how can we achieve the end goal that we're after more effectively than the current approach that everybody seems to be taking? And at Alien Vault, our focus is, well, what if we try to be a bit more strategic, right? What if we're taking a slightly different approach that is value-based or benefit-based, and instead of saying, all right, let's collect everything in an organization and then see what value we can get out of it, why don't we say, what data is in the organization that can give us value? And then let's focus on that, right? And, you know, there's still some element of log management that has to go into it. There's, you know, a SIM correlation and everything else that has to go into it, but we can significantly pare down the amount of information that we're collecting and bringing into a system if we're very, you know, sort of value focused on that data. And this is basically a methodology that we can use to pursue that goal or to pursue that effort that I'm going to present to you today. So it's basically a combination of three questions. We start with a question of why. Why do we need the log data? If we're considering collecting some log data from a particular device, why do we need that data? What's the intended result in mind? And if you don't have a good answer for that, you don't need the log data. You know, that's pretty much like if you're going to adopt this type of methodology, that's a really good place to start. If we don't know what we're going to do with this data, then we don't need it because it's going to cost us money and we're not going to get any value out of it. That idea that, well, we'll just collect the data and see what value we get out of it, it doesn't work. SIM doesn't work that way. Log management doesn't work that way. And it's going to cost you a ton of money and a ton of time to do it. So let's start with answering that why question first. Why do we need this data? What do we intend to achieve by collecting it? And then from answering that question, if we understand what the intended result is, then we can ask the next question of, okay, well, what specific data from that particular data source do we need in order to achieve that desired end result, right? So each device that we can potentially collect logs from is going to be, you know, a data source with immense information that can potentially be provided. So do we need 100% of the logs that are generated by that device, or can we just focus on authentication data or communication data or something like that, right? So what log data do we need to get our intended result? And then once you answer that question, you can dig a little deeper into the, you know, who question, which is who will this data that you're collecting pertain to? So can you focus it down to a specific user group or a community that, you know, has, you know, some element of access that you're particularly interested in? And by asking that who question, it actually helps to start it helps to start shaping how you're going to make use of the data that you're collecting. So, you know, the why and what questions help you figure out what data to collect, and then the who question helps you figure out out of the data that you're collecting, you know, what element of that should you be focusing on, and what can you do with that data? So this who question is really critical as well, just to help you sort of further filter it out and build some actionable intelligence off of it. So the why, what, and who questions are really critical, and starting with why is just really the biggest piece. Even if you just address that question, you're going to be in a much better place than kind of coming at it haphazardly and saying we're just going to collect everything in the organization. So let's take some examples into consideration, starting with firewall data. And there's a couple of scenarios where, or a couple of data sources in any organization that absolutely you should always collect data from in order to get security visibility, in order to be able to do effective log management. And a firewall is certainly one of them. But let's apply this methodology. So starting with why do I need the firewall logs? And you know, let's identify an answer to that question. Let's really get down to, well, what do we need to achieve by collecting this firewall log data? And you know, the most common answer that I see there is, well, I need to see what's getting into my network. And you know, when we look at it from a firewall logging perspective, there tends to be, you know, an approach around the stuff that's getting denied is the most important information for us to look at. And I completely emphatically disagree with that point of view. The firewall deny logs might be interesting for some certain use cases, but from a security standpoint, I want to know what's getting into my network. If the firewall has blocked it, that's great. That means the firewall did its job. We don't have time to sit around and look at what are all the IPs that are getting blocked by our firewall and what are we going to do about them. We need to be more focused on what's getting into our network and potentially creating problems, right? And once we solve for that challenge, then we can go back and start looking at, okay, well now let's take a look at the firewall denies and figure out what else we can do to start being more proactive from there. But really that why question in the case of firewall data is, I really need to see what's getting into my network. That's the most common response there. And so, okay, well, what logs do we need to get that result? And the answer to that is firewall permit logs, right? So the deny logs are the ones that are almost always collected, and a lot of folks tend to ignore the permit logs. And obviously, we're not going to be able to answer question number 1 without the data that we've identified in question number 2. So making sure that your firewall is configured to log the permit logs is really kind of or the permitted connections is a key element to being successful with your firewall data. And then the third question of who, so who does this log data that we're collecting pertain to? A good way to look at firewall data in this case is like, hey, I'm interested in the activity that's associated with bad IPs out on the internet, so blacklisted IPs or domains, any kind of communication coming in or out of my network that's associated with a known bad host. That's valuable to me, right? Like I really want to be able to focus on that traffic that I know there's a good chance it's going to be problematic. And the firewall can give me really good visibility on that. And so this actually, again, this who question actually gives me some idea of, okay, now that I'm collecting these firewall permit logs, what specifically am I looking for there that's going to indicate a problem is present? And that's what that who question is answering for us. Okay, so let's have this example illustrated here a bit, just to take a look at some actual firewall log data. This is basically a series of events that are coming in from, or raw logs that are coming from a Cisco PIX that we might pick up in a typical log management solution. And this is a really common scenario. What we're looking at here is a number of denied TCP connection denied messages that are coming or that are being reported. And this is something that folks tend to really focus on in terms of firewall logging, and the firewall focuses on this too. So if we're to kind of dissect this event here for a minute, one of the things you'll see is this string right here where it says %pix-2-106001. There's a couple of interesting bits of information in this little string. So first, the %pix is letting us know obviously that this is a PIX firewall that's sending us this log data. The -2 is basically this number here is the severity associated with the particular log message that's being reported. And in the Cisco world, the lower the number is, the higher the severity is that's associated with that particular log message. So a severity of 2 is identified as basically a pretty severe incident that's occurred, right? And then this number here, the 106001, is basically the event ID. So this 106001 ID is always associated with a TCP denied or with a connection denied type of log message. Okay, so that's kind of in a nutshell what this string is telling us. And if we look at this bottom message, this is actually what we're probably more interested in, which is this is a communication that was permitted outbound, so coming from inside our network going out to the internet. And so the firewall permitted this communication, and this IP address here, this 95.211.169.207 host, is actually a known bad host out on the internet. So this is a bad IP that has some significance associated with it. And we've got basically by this log message, we can see that we've got a host inside of our network that's communicating with this known bad IP out on the internet. Now, the question that you're probably asking at this moment is, well, how am I supposed to know that that IP address is a bad IP address? And I'm going to answer that question for you. I'm actually going to illustrate that so that you can see how we would answer that question. But you can see here a couple of problems. First off, the majority of traffic that people collect from their firewalls is this stuff, when in reality, this is the stuff that's really kind of significant from a firewall standpoint. This is a communication that the firewall is permitting that probably is going to result in some kind of compromise inside of my network. Okay, and the other thing that's interesting to me about this is how the firewall reports it. So again, this is a PIX event with a 302001 event ID. That doesn't really mean much, but what's interesting is this number here is a value of 6. So remember what I previously said is that the lower the number is, the higher the severity is. In this case, the firewall is basically telling us, hey, this is an insignificant incident or an insignificant log message. It's a severity of 6. It's a very low value, not very interesting, right? And I would, again, emphatically argue that that's the exact opposite of the case. In my opinion, this communication that's permitted through the firewall is more significant than the communication that's denied by the firewall, right? Because this traffic represents, some actual potential compromise inside of my environment. So even, I guess my point here is that even looking at the difference between the deny and permit messages, the severity attached to them by the device vendor is kind of out of whack with what reality is. And this is just kind of an artifact of the old days of security. In the old days, perimeter security was really all we had, right? Firewalls were all we had, that and some access control. But the firewall basically telling us, hey, somebody's being rejected by trying to get into through the perimeter. This is a serious incident. Actually not so much anymore. What's more serious is the actual communication getting into the network. So I kind of beat that horse to death. Let's move on. Another example, OS logs. So again, going back to the kind of best practices of what do we focus on from a log management standpoint. Well, we talked about, firewall permit logs. We're also talking about, OS logs. You've got to have information coming in from your operating systems to make sure that you get visibility around being able to detect the types of activity associated with what your users are doing or what some potential malicious users might be doing. So again, going back to these three questions, why do I need OS logs? Well, at the most basic level, I need to detect unauthorized access attempts and account lockouts, right? Like I want to see when any kind of suspicious activity is going on with individual accounts. And so if that's the end result, well, what log data do we need to get there? And the answer to that is, well, I need OS authentication failure logs and account lockout logs. So anytime a user attempts to log into a system and fails, we want to get visibility on that. Anytime an account gets locked out due to repeated login failures, we want to get visibility into that, right? So those are two sort of significant log sets that we can focus on. And then with the who question, who will the logs that you're collecting pertain to? In this case, the log data that I'm most interested in are admin level accounts, right? So I really want to focus on those login failures associated with admin level accounts. You can have circumstances where a typical or an average user account might fail to authenticate a number of different times, and it's an average user. People forget their passwords. Things happen, right? This is that kind of humans meet technology thing that we talked about early on. So that's in a lot of cases just kind of a normal situation for us to deal with. But when we start seeing admin level accounts that are failing with their authentication efforts, that's something that we can almost guarantee right away is a problem, or at least something that probably needs some investigation. So that's a really easy thing for us to focus on, and it's not entirely a major challenge in order to identify that data. So again, that who question helps us figure out what are we doing with this data after we've collected it. And, well, in this case, we're focusing on those admin level accounts. And certainly we want to see, if there's authentication failures from regular users, yeah, absolutely we want to see that. And if there seems to be a pattern or a significant trend there, then we're going to want to, investigate it as well. But sometimes, just focusing on the low-hanging fruit, hey, admin level accounts are really significant, so that's an easy one to make sure we're addressing. Now, one of the challenges with operating system audit logs is that they generate tons and tons of information, right? So this is, back to that log management conversation of like, okay, how much data do we need to collect in our environment? Are we really going to get all of this information in and do effective correlation on it and then have to store it long term? And the answer there is, yeah, we can absolutely run into some challenges with collecting operating system audit log data, and this screenshot is an illustration of that. I mean, basically, at the top of the screenshot, we've got four audit log messages that we're looking at in the security event log for a Windows server, and those top 4 messages are actually all associated with a single logon. So one logon generates, in some cases, as many as 7 individual events, which indicate that that logon occurred. It's usually about 4. It can be more in a lot of cases. And so that's literally 4 times the data than what we actually need to collect. So that the activity that we're actually interested in is, hey, when somebody logs on, that's what I need to know. I don't need 4 separate events indicating, hey, that there was a Kerberos service ticket operation. That's kind of, excessive detail. So we can really focus on, identifying those login events and filtering out the rest. So for example, that 4624 event at the very top is going to show us that the logon occurred. It's going to show us what time that logon occurred at, and it's also going to show us the username associated with that logon and the system that the logon occurred from and to. So all of these things are, kind of the critical components that we need to be able to get, and we can get all of that from that 4624 event, as opposed to having to look at 4 different or 5 different individual event messages to piece this information together. So if those additional 3 events aren't contributing any value, we don't need to collect them. We don't need to store them. We don't need to correlate them. Let's just drop that data, right? So again, another common example for operating system audit level kinds of information. It can really inundate you with data. Be strategic. Make sure that you're focusing on the data that's of most interest to you. All right, let's talk about one more example. I get this one a lot too. I talk to a lot of folks where they're talking about collecting log data from their switches and routers, so their network infrastructure. And this is certainly another interesting area where it could be a good best practice to make sure that you're monitoring your network infrastructure, right? Like, we want to know if somebody's interacting with our routers and switches, or configuration changes are being made on those systems. That's some significant information for us to keep track of, right? So it's definitely a best practice to monitor the network infrastructure, but what are we looking at or what are we intending to achieve by monitoring that? And it's, what I just said is, hey, if somebody's interacting with my network gear or making config changes, I want visibility on that. And so a lot of times folks will just configure, sort of a blanket logging policy, and they'll just take in everything that a switch or a router generates and store it long term and do correlation on it and everything else. And the value that you get from that is pretty limited, but the cost can be quite high. So if that's the case, what log data can we focus on? And the answer to that question is, well, we can focus on authentication and authorization data from that system. So for example, a TACAX server, if you have a TACAX server deployed in your environment, or if you don't, maybe you should consider getting one and track authentication activity to your network gear by configuring your systems to actually your network gear to authenticate against the TACAX server, and then get the logs from that guy. Or you can configure AAA authentication directly on the router or switch itself, and then just focus on collecting those log messages, right? So instead of getting everything from the router, focus on those AAA authentication, authorization, and accounting type logs that are going to come from your network gear. And that's really going to help you get visibility into who's accessing the system, what changes they're making, things like that. And in this case, the who question is really, kind of just comes down to, listen, I want to know if anybody's connecting to my network gear. So because of the sensitivity of that infrastructure-related, access, basically we don't need to boil this down any further. So the who question is really simple in this case. So let's take another illustration of this particular example. One of the challenges that I mentioned is, just blanket logging from these devices. They generate an immense amount of information. So we're looking for, login failures, and the reality is that you're probably going to see literally tens of thousands, if not hundreds of thousands of interface state change log messages in a given week or a month or whatever, and in reality you'll probably only see a couple of login or login failure type messages from that same equipment, right? And so the thing that we're after is these login and login failed type messages at the bottom here, and we literally have to process tens of thousands or hundreds of thousands of interface state change messages in order to find those. So this is really that needle in a haystack kind of situation here, and that's definitely not ideal, right? We don't want to have to store all of this information and analyze it and everything else just to figure out, hey, somebody logged into the system. We'd really like to be able to just focus on that log data. But one of the challenges from the device side is, well, how do you configure logging on the device side to be able to focus on just that interesting information? And the answer is you can't. On the device, you really don't have that much control. So a couple of examples here. I mean, again, if we look at this log data, when you come in and look at the severities associated with these messages, this is basically the same principle of those PIX logs we were looking at, right? So this is a link type message where it's showing the interface is up, down, and the severity is a value of 3. If you look at this interface, it's actually an Ethernet interface on a switch where it's showing the status of that interface changed to up. So that means the interface came up. Somebody plugged in to that switch port. Somebody turned on their laptop or turned on their desktop, and the switch port became live. And that could potentially be some interesting information if you were doing some really, really intense forensic investigation, but I can tell you right now that 98% of organizations out there that are collecting this data aren't actually doing anything with it. Maybe from an operations standpoint, but certainly not from a security standpoint. They might be using this type of information to troubleshoot issues at an operational level on a router, but seeing switches, interfaces coming up and down is terribly uninteresting from a security point of view. And the fact that there's a severity of 3, a severity of 5 associated with each of these is kind of a bummer, because the significance of these log messages is basically saying, hey, this is a really important log message, when if you look at a severity of 5 for a login success, they're basically saying an interface changing from state up to down or from state down to up is more important than a login success. in the device, right? And I wholeheartedly disagree with that. I think a login to a device is absolutely more important than, you know, a simple switch port status change, right? But the net effect of this for you from a configuration standpoint is if you're trying to control which logs get produced by the device, it's typically done by severity, right? So you can say, I want to log anything that's informational level, or I want to log anything that's an error level or a warning level, and that's what these severity numbers reflect on the system when you're configuring logging. And so that means that if you're going to enable the logging level that's needed in order to be able to see these login success messages, well, then you're also going to have these line protocol up-down messages included in the logs as well. And then again, the login failure having a severity of 4 is basically a less severe issue than the interface state change as far as the switch is concerned. So again, these are just a couple of examples of how, you know, from the device side, you really don't have a lot of control over what data gets logged and how. So the challenge there is, you know, how do we get down to the stuff that really matters? Okay, so a couple of explanations for that is really on the if we kind of actually will work back through some of these examples, and I'll give you some details on this. So how we can address these. For starters, when we're talking about just going back up to the firewall log data, so you know, making sure that we're collecting the permit logs. The Alien Vault product, when it brings this information in, is actually going to be able to process the data around you know, what we call our Open Threat Exchange, and I'll talk a little bit about what this is in a minute. Essentially, that Open Threat Exchange is going to tell us, you know, hey, this particular communication is associated with a bad IP out on the internet. So that's one of the ways that we can help you address that challenge, and I'll show you an example of that. From the operating system data, we've got filtering policies that we can put in place that help you sort of weed out these excessive events so that you can focus just on those logon messages. And the same goes with this particular example of the router and switch data. We can filter out these line protocol messages or you know, get really specific on the login failed types of messages that we want to see. And we've got a correlation engine built in that allows us to focus on that who question, right? So we can correlate the data against, hey, is there you know, some kind of login failure occurring that's associated with a sensitive account or an administrative level account or something like that. So we can really get very focused on the information that's being collected there. So I'll show you some examples of that before we get into the other kind of components of the Alien Vault solution. I'll just kind of walk you through some illustrations of this information. Okay, so couple of quick things, starting with the firewall data. If we just jump in here to the security events view, we're able to see, for example, you know, a filter. We can apply a filter where we're looking at just firewall data, for example, and when we're watching this firewall activity, you can see, you know, there's going to be a lot of information that the firewall generates, right? There's these teardown messages, there are these user messages, a bunch of, you know, permit messages, and there's lots of communication that's occurring here, you know, between multiple hosts on the network. But the things that are really interesting, I can drill down to pretty simply just by applying this IP reputation activity filter. And when we put that in place, basically what the Alien Vault system does is it compares the IP reputation database from our Open Threat Exchange with the firewall events that we've received inside our network, and you can see really quickly here that, hey, we've got some interesting issues that are reflected by this. Okay, so we've got a single host inside. In this case, it's resolving back to a specific username of Mike. This particular host has ongoing communications with multiple systems out on the internet that are known to be bad actors. Okay, and I can tell that because each of these IPs has this little target here next to it. All right, so when you mouse over this, it's going to tell you, hey, this IP address out on the internet is a known malware domain. This IP address out on the internet is a known command and control server. It's a known malware IP and a known malware domain. So having that understanding that this activity that's occurring is of significant issue is really providing a lot of context and value on top of the firewall log data that you're collecting, right? So this is that who question that we're answering, and really we wouldn't have been able to get here if we didn't have the proper firewall data to show us this activity, right? So if we were just looking at deny logs from the firewall, we would never see this. And in terms of sort of performing analysis on this data as an analyst, one of the things that I'm looking for is, okay, the fact that we've got a single host communicating with multiple known bad hosts on the internet, that's really significant, right? Lots and lots of communication happening here. And then if we look at it over time, one of the things we can see is, okay, is this communication ongoing? Meaning, is it something that happens multiple times a day, every day for an extended period of time? That's an indication that it's machine-based behavior as opposed to user-based behavior, right? And so that's one of the things that you're trying to kind of assess when you're looking at this data. Is this something that a user is doing that's just part of their normal daily work routine, or is this something that is being code-driven or malware-driven potentially? And given that all of this communication is happening with known bad malware IPs or malware domains, is a pretty strong nudge towards the potential that this is code-based activity or malware-based activity, right? We can actually drill down into these IP addresses from our Open Threat Exchange and get quite a bit of information about the activity that's been reported for this particular host. So we can see that it's actively malicious. We can see a timeline associated with that activity, and we can get details about the types of malicious behavior that have been reported for this host. So it's a known command and control server. There are a number of different ZooSpot variants that have been reported as being seen interacting with this particular host. It's been reported as a malware IP, so we've got a number of different reports on the type of malware that this particular system is impacted with. And we've got specific URLs that show you kind of the malware that's being distributed from the system. So lots of good information that we can provide you with here while we're looking at this context applied to your firewall data. So that's the way we address that sort of couple of questions with the firewall logs. Now, in terms of your operating system audit log data and your network infrastructure logs, in terms of filtering that data, there's a couple of things that we can do here. So we have this policy mechanism that's built in, which essentially allows us to get really focused on the types of data that we want to collect. And so we can build out a policy that says, hey, any source, any destination associated with the events, and then we can drill down into actual event types. And we can look at, for example, with our network login infrastructure or our network infrastructure, our network gear, looking for login specific events, we can get really focused on the types of data that we're after there. So let's say, for example, if we did a search for Cisco here, this is a Cisco router that we are getting that we can collect log data from. We'll apply a little group name for this here, and when we're looking at this particular data source, we can tell the system to focus on specific events that we want to collect, right? So, for example, this is all the AAA authentication type of stuff that we would be really interested in from an authentication standpoint, right? On the other hand, we've got, our line proto, event up-down types of events that are going to come in, and we can actually filter all of these out. So we can tell the system, like, you know what, I don't want to do correlation on this data. I don't want to do, logging of this type of data. So we can get really focused on excluding that data simply by coming in here and applying a policy consequence. So once we've identified that log data that has been that is creating lots of information for us that we don't really want to see, we can apply a simple policy consequence here that says, you know what, I don't want this data to go into the SIEM, and I don't want this data to go into the logger. So correlation will not happen for these logs, and the storage of the data will not happen either. So essentially the data will just be discarded. So the policies help you focus on that, and then the directives help us focus on essentially identifying, who is the authentication that's occurring most relevant for, right? So we can use correlation directives, for example, where we have a number of these built in that are looking for repeated authentication failures, for example, from a particular host, and followed by, a successful authentication. And what happens with this is that, it's kind of focused on just any user, right? But we could augment this and say, you know what, I really want to focus on repeated authentication failures for my administrative level users, right? Or my admin type users. And so it's just a simple augmentation of this particular rule that would allow you to achieve that. And the same goes for your authentication information that's being reported from your network infrastructure. So you could generate or build a rule that basically gives you visibility around any login attempts to that network gear. And when you get that rule set up, if it detects that type of activity, the net effect of that is going to be an alarm, which is what I'm going to show you here. So basically, this is the view that you can use to see, hey, there was some type of problem detected in the environment. An alarm is going to be generated by those correlation directives, and those alarms are going to be represented as these little bubbles here. So you can see, for example, that there's some kind of brute force authentication attack that was detected in the environment. This problem that's being represented is going to be sort of raised to your attention really easily as a result of this advanced correlation that you can do on the data that's coming in. And we're able to get there because we're really focused or really strategic about the data that we're collecting and understanding the problems that we're trying to solve with that. So that's kind of how the product helps you solve some of these problems. Just to circle back around to some of the capabilities of the Alien Vault platform, another way that we help you get really focused is by embedding a couple of key technologies into the platform. So threat detection, vulnerability assessment, all of these things are built into the Alien Vault solution, which provide immense visibility and value from an analysis standpoint, or just a monitoring and awareness standpoint. And then we combine that with the Open Threat Exchange, and I mentioned that I'd get a little bit more into what that is. Basically, this view is kind of an illustration of all of the IPs out around the internet that we're tracking on a daily basis. We have literally over 200,000 IPs that we have flagged in our database as being systems that are known malicious hosts. And with that, we're able to push that information about these bad IPs down to your Alien Vault installation to give you this kind of visibility. So the way we get this information is through our installation base, as well as a number of other sources like partners that we've integrated with. And this information comes back to us. We have literally 8,000 collection points, or more. It's closer to 10,000 now collection points out on the internet that are essentially our customer install base, that are reporting information back to us about attacks that are being detected on a daily basis. And we're taking those IPs in, we're validating them, we're doing a bunch of analysis around them. All that information that's being collected, that's displayed for you on that threat details page that I showed you. Our team is pulling all that information together and then pushing it back out to our customer base so that they can get that added value and that context on top of the log management efforts that you're putting forward. So that, in a nutshell, is the Open Threat Exchange. There's a lot more to it than that, but we're kind of running out of time here. So I wanted to sort of drill down and identify some questions that we can talk about and some potential answers. So let's get into the Q&A really quickly. Before we do that, though, I did want to point out that you can download a 30-day free trial of our solution from our website. We also have an interactive demo there that is sort of a, it's kind of a very or a very slimmed down version of our product that you can get in and poke around on a little bit. We have to secure that system, so it actually kind of limits some of the capabilities that you have, but nonetheless you can get a login to the system and see some basic stuff there. And by the way, the Alien Vault solution starts at just $3,600 for one of our asset-based licenses, so it's very effectively priced. Very low entry point for those smaller organizations that need this kind of technology but don't have huge budgets. So that's a couple of things that I wanted to point out for you. Let's go ahead and get into some Q&A, Vince.
All right. So this one kind of was about when you were talking around the traditional problems that are facing with SIEM. The person asked, you choose what goes into your SIEM. So what you're saying is that a lot of companies are unhappy with the way they set up their SIEM. Is that one of the problems that people are facing, or?
Yeah, that's exactly it. I think, I've been in the SIEM industry for about 10 years now, and in that time, what I've seen consistently happen is that, the Alien Vault solution is a great platform for solving problems like this, but really what I was intending to do with this presentation is, regardless of what SIEM solution you choose, trying to help add some value here in terms of how can we be more effective with the solution that we have deployed or going to deploy, etc. And my personal experience with that has been that the majority of folks out there are taking this approach of trying to integrate everything under the sun that generates a log message with their system. And the net effect of that is that the performance of the SIEM is very bad, the storage costs are very high, and the value returned is minimal. And so the organizations that I've seen be very effective with SIEM deployments are those organizations that are extremely focused on what they intend to achieve with their SIEM implementation. And this improves their time to value. They're able to start getting benefit from the deployment quickly because they're focusing on specific data sets and what they're going to get out of those data sets. And then again, they don't push the system over the limit of what it's capable of because of that strategic and focused effort. So that's basically the point.
All right. One more quick question here is, do we need to allow Alien Vault access to the internet, or is there a way to make offline updates or for any software update or reputation update?
Yeah, that's a great question. So the initial activation requires a connection to the internet, but after the appliance, it can either be a virtual appliance or a hardware appliance. After it's been activated, you can move it to an isolated network that does not have internet access, and we have an offline update process that allows you to push updates onto a USB drive, for example, and then bring that USB drive over to the Alien Vault installation and update it that way. The Open Thread Exchange updates come down every 30 minutes, and that requires basically internet access for that to happen. You know, I mean, you're probably not going to do an offline update every 30 minutes, right? But for the actual software updates, that definitely is available.
Great. So unfortunately, it doesn't look like we'll be able to get to all of the questions. I know there was a number of great questions that came in, so we'll be sure to have someone follow up with you. But we do also want to just let you know that we do have a weekly live product demo that we have every week. We have that tomorrow. It's every Thursday at 8 a.m. I'll go ahead and put a link in the chat section for everyone, so if you want to join us tomorrow, and we'll try to get through some more of these questions there. So I'd just like to thank everyone for joining us and hope you all have a great day.
Thank you, Vince.